Thank you for downloading the Drone Radio Show podcast. Because of great listeners like you, my podcast recently surpassed 1 million downloads, which I'm extremely grateful. If you're a regular listener of the show, I'd like to get your feedback on how to make it better. Please take the Drone Radio Show podcast survey found on the podcast webpage at www.droneradioshow.com. Thanks again for your continued support. Now on to today's podcast.
The operator will call the patient so that the patient can open the door, and the teleoperator will remotely navigate the drone inside person's home using the first-person view or video feed. And then a drone would then be landed at a safe spot identified by the patient where the telehealth session will be carried out.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 361. Do drones have a place in the health industry? If you ask today's guest, he would say they most certainly do. Dr. Manish Kumar is professor at the University of Cincinnati, where he directs the Cooperative Distributed Systems Laboratory and co-directs the UAV Master Lab. His research interests include unmanned aerial vehicles, robotics, decision-making and control in complex systems, multi-sensor data fusion, swarm systems, and multiple robot coordination and control. At the University of Cincinnati, Manish and other university researchers have innovated a way to integrate basic telehealth services into a drone, potentially expanding the bounds of what previous innovators ever envisioned with these two technologies individually. The research team collaborated to develop a semi-autonomous prototype that can be dispatched directly to people's homes. The drones are big enough to carry medicine or medical supplies, but small enough to maneuver the tight confines of a home using navigational algorithms developed by University of Cincinnati engineers. A novel aspect is that the drone will also integrate cameras and a display screen so patients can talk to healthcare professionals from the comfort of their home. In addition, the drones will carry a waterproof box the size of a small first aid kit to deliver medical supplies or collect self-administered lab tests. Manish is a member of the American Society of Mechanical Engineers, or ASME for short. He has served as the chair of the Robotics Technical Committee of the ASME's Dynamic Systems and Control Division, and as an associate editor of ASME Journal of Dynamic Systems, Measurements and Control. In this edition of the Drone Radio Show, Manish talks about the University of Cincinnati's research into drones and the innovative use of drones for telehealth. But before we hear from Manish, I want to thank those of you who are supporting my funding campaign. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to droneradioshow.com/donate. And by the way, if you have a great story on the use of drones that you'd like to share in a podcast, contact me at randy@droneradioshow.com. So let's learn how drones can be used in telehealth with Dr. Manish Kumar of the University of Cincinnati. Let's pick up the interview where I asked Manish to introduce himself.
My name is Manish Kumar. I'm professor of mechanical engineering at University of Cincinnati. I'm also director of graduate studies in mechanical engineering. Apart from teaching courses related to robotics, controls, and intelligent systems, I spend a lot of time carrying out research on drones. In particular, I'm engaged in various aspects of drone research, including design and fabrication of novel kinds of drones, navigation and control, and their use in a variety of applications.
Manish, how long have you been conducting research into drones at the university?
I started at University of Cincinnati in 2007, so it's been close to 15 years.
I understand the university has been researching a variety of civilian use cases for drones. Can you share the scope of that research?
Some examples are that we are building drones and associated systems that can be used to gather information in large-scale disaster scenarios such as wildfires. Likewise, we have been developing drone systems that can be used by first responders for indoor emergency situations such as fire, chemical spills, or active shooter situations. We have also been working on developing drone systems that can be used for monitoring traffic parameters on highways or intersections. Another prime area of our work has been developing means to allow integration of drones in national airspace systems. That includes means to manage their traffic and track their positions.
Wow, that's quite a bit. We don't have time today to talk about all of those use cases, but I do want to talk about the Telehealth and Drones initiative. Can you describe it?
So we call it Telehealth Drone Project, and instead of using the word telemed or telemedicine, because our scope is much more than what a typical telemed drone does. So in this project, we are currently developing this drone which has the capacity to do telehealth as well as bring medical health kits containing medicines or diagnostic medical devices individuals' home. The objective is to provide a multifaceted, engaging healthcare experience to people in need from the comforts of their home. The product enables secure and effective communication between the provider and the patient, and has an ability to scan patient's indoor environment for any needed intervention.
Why did you undertake the project? I mean, what's the problem that you're trying to solve?
I have been working in developing technologies for indoor drones for quite some time. Before we started working on this, we were working on a Department of Homeland Security project for developing drones for first responders. So those drones that can go inside home or indoor environment and gather information from there. At the same time, there's a lot of work that I've been doing in using these technologies for improving care of older people from their homes. So an ability for them to live independently at their homes. So with that in mind, we connected the two things together as a drone that can provide telehealth services to older adults with chronic illness. And that has been our targeted population that this drone will provide service to. This targeted group is more vulnerable from a health perspective, and they need to visit health clinic more often. Also, a lot of them suffer from mobility issues. So our motivation has been to develop this telehealth drone device that can go into their homes and provide the telehealth services to them. So these have been some of the motivations. And the kind of problems that we have been trying to solve are kind of multifaceted. One is inconvenience of brick and mortar healthcare facilities. Recent studies have indicated that home and community-based care for older adults is preferable alternative to institutional care because it not only promotes independent living and overall wellness for older adults, but also provide tremendous cost benefits. Also, one of the means to provide in-home care is telehealth products like the telehealth devices that you can use. But those require technological literacy, and they cannot deliver medicines or diagnostic devices or retrieve tests that we plan to do with the telehealth drone. The third aspect is that of the healthcare provider. There's a lot of loss of revenue due to no-shows and cancellation. In fact, historically, 55% of the health appointments are missed. Missed appointments compromise early detection of serious problems and also are economic burden to healthcare providers, costing healthcare industry about $150 billion annually. Fourth problem that we are trying to address is that of the shortage of healthcare workers. Such drone services will make the healthcare delivery more efficient and put less burden on the healthcare workers.
Is the service intended to be fully autonomous, or will a human be doing the flying?
It is a mix of the two. So in a typical mission, the drone would leave its facility to reach a person's residence at a pre-scheduled time. The flight from that facility to the residence, which is carried out in the outdoor environment, will be completely autonomous. But once it reaches the patient's residence, a teleoperator would take over the operation. The operator will call the patient so that the patient can open the door, and the teleoperator will remotely navigate the drone inside person's home using the first person view or video feed. And then a drone would then be landed at a safe spot identified by the patient where the telehealth session will be carried out. In this session, the patient will interact with the care provider using a two-way audio interface. Patient will also have opportunity to retrieve medicine or tests such as oximeter, EKG, or thermometer, or take simple tests such as nasal swab under supervision of the care provider. Once the telehealth session is concluded, the drone will retrace its path back to the door under remote operation of teleoperator. And once outdoors, the drone will switch to fully autonomous mode and fly back to its facility.
How are telehealth drones different from the drones that are currently delivering medical supplies?
Currently available telemed drones are able to deliver medicine on people's doors. Such drones are not designed to go inside people's homes. Indoor operation is a whole lot more different, as well as technologically difficult as compared to outdoor operation. And such drones, telemed drones, are not equipped to do the telehealth services like establishing two-way audio video session with the care provider. Their primary objective is to deliver medicine package to people's homes.
What are the challenges in developing this sort of telehealth service?
So technologically, there are several challenges. As I was saying, that this kind of drone not only carries out operation outdoors, but goes inside people's homes. Now, when we are talking about drone operation inside home in close proximity to human, as well as other obstacles in indoor environment, the safety and reliability of these drones become very important. So that's one of the technological challenge over here, how to have a drone that operates safely and reliably, not only outdoors, but also indoors when working closely with human and other obstacles. Now, this problem becomes more challenging due to the fact that when you go in indoor environment, you lose the GPS connectivity. So you do not have a way to localize yourself. Also, the capability of establishing the onboard intelligence that would guarantee the safe operation in proximity of humans and obstacles is challenging. Another aspect of challenge comes from the fact that we would like the drone to be, reliable under all circumstances. So it needs to have onboard intelligence to handle some unforeseen circumstances, such as some sensor failure or lost communication. So those are some of the technological challenges.
What's the status of the project?
At this point, we have been working on this project for about 2 years when we have been developing the prototype. So right now, we have a lab prototype which is built with most basic capabilities on the drone. We have tested the drone for its essential functionalities in lab. And our team has also finished a pre-accelerator program at University of Cincinnati. And we are currently carrying out market studies and customer discovery as we are building a viable business model. We have also a full patent that we filed last year, a non-provisional patent from University of Cincinnati.
Has the ability to use a drone to interact with a patient been tested to your satisfaction?
So far, we have built the drone and we have carried out those functionalities in the lab environment. We have not yet tested it in any patient's homes yet. That's our next phase of work. We are currently working with a retirement community here in Cincinnati, Maple Knoll Village, who have kindly agreed to test these drones with some seniors, volunteers who will be our subjects for carrying out tests.
What have you learned so far through this project?
So one of the things that we have learned that sensors that we use are sometimes not very reliable, and they do not work in all operational conditions. So when we talk about achieving autonomy with safety guarantees, that needs utilizing not one kind of sensor, but multitudes of sensors with heterogeneous capabilities. So some can work even if there is no light or lack of light, or some can work when you have not ideal conditions like a dusty environment. So we have been learning that you need to use multitudes of sensors to develop that robust autonomy that can guarantee safety in a variety of operational conditions. We have also been learning the human psychological aspects of using these drone technology in people's homes. Say, for example, while several people are very excited to see these new technologies, some are also apprehensive about the noise that these drones would make in their homes, or the kind of air draft that they will create. How will it work in their homes? Some of the people are apprehensive about that.
Where does the program go from here?
The first thing that we want to do is to advance the prototype that we have built to a minimum viable product. We are exploring launching a startup to commercialize this idea. With that objective in mind, we would be carrying out extensive customer discovery that would help us develop a consistent and profitable business model.
Is there anything that we missed that we should talk about?
I would like to thank and acknowledge the collaboration with three other colleagues in this effort, Dr. Debbie Samsel from College of Nursing, and Dr. Xiangyan Lee, and Dr. Victoria Wangya Anderson from College of Allied Health Sciences at University of Cincinnati. I would also like to thank some of the students who have been working on developing this prototype and testing the prototype in our lab.
And for my final question, Manish, what message would you like to leave regarding the future of drones to deliver home health services?
Recent advances in drone and associated technologies such as communication and sensing has really opened up a lot of opportunities for their use in a variety of applications. But we are especially excited about our telehealth drone project because of its tremendous societal impact. Such a device would allow older adults to live more independently at their homes, would enhance their health and make healthcare more accessible to people living in remote areas or with limited means.
That's it for episode 361 of the Drone Radio Show. I hope you enjoyed hearing from Dr. Manish Kumar of the University of Cincinnati. I want to thank Manish for taking the time to speak with me. If you want to learn more about the University of Cincinnati Cooperative Distributed Systems Laboratory, or want to connect with Manish, check out the website at ceas.uc.edu. If you like the Drone Radio Show, please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.